Hi guys, how's it going? My name is Maddie, and I'm an intern with Coral Restoration Foundation here in Key Largo, Florida. Today we're going to be conducting an experiment that shows us how ocean acidification impacts coral reefs. But until we get to the actual experiment, we need to make sure that you guys have all of your materials lined up and ready to go. So feel free to pause the video at any moment if you need to run and grab these items. So to start us off, what we will be working with today is a piece of chalk. I'm just using sidewalk chalk. A leaf, really anything from your backyard will work. A dark colored rock or pebble. A piece of limestone. Vinegar, and then cups or bowls to put all of your items in as we experiment. So if you guys have all of those materials at your workstation, you're ready to start, let's move on to step 1. So I have actually already gone ahead and done step 1. All I need you guys to do is put each of your items, like the chalk and the leaf, into their own separate bowl or cup. You basically don't want to mix the chalk with the leaf or the rock with the limestone, for example. To get the best results, you need to make sure that everything is separated. So while you guys are getting organized doing that for step 1, I'm actually going to talk a little bit about the goal of this experiment. We all want to know what we're doing today, right? So basically the goal of the experiment is to see which of these items has calcium carbonate in it. And I know that sounds really scary. That's a big word that a lot of people probably haven't heard of before. But don't worry, I promise it's really important, especially to our corals. So calcium carbonate is actually a chemical compound that makes up a lot of naturally occurring things in the environment. And one of those things, Coral Restoration Foundation is definitely pretty interested in, is this right here. So that limestone sample I asked you guys to grab. That limestone actually makes up the foundation of our coral reefs. And it's laid out by these little tiny animals that make up corals called polyps. So these polyps, when they're trying to grow and expand a colony, they actually lay down a layer of calcium carbonate, and that will turn into this harder substrate called limestone later on. Now, it's not exactly like a skeleton you might see when you go to the museum, for example, but this limestone skeleton, it provides the same basic things to corals, and that includes protection and structure. So really important for those corals to have that limestone skeleton to help them out as they're growing, surviving, and thriving in our oceans. Now, if you guys have all of your materials laid out, they're in separate bowls and cups, as we said for step 1, we can actually move on to step 2, and that is going to involve this vinegar right here. So vinegar is an acid, so much like things like lemon juice or orange juice, these acids have a lot of hydrogen ions in it. Now, things like calcium carbonate, which is a base, also similar to bleach, have a lot of hydroxide ions in it. And I know that sounds like a lot of gibberish, a lot of words. Basically, what we're going to try and do is mix an acid with a base to see what the chemical reaction is. So, for example, if we poured vinegar into, let's say, the leaf, for example, and we saw something happen where maybe bubbles or fizzing started to rise to the surface, we can actually assume that there's a base in that leaf, and it's probably calcium carbonate. So for step 2, what we're going to do is pour this acid into each of these items. And while I'm doing that, I want you guys to continue for step 3, which is going to involve making observations. So see which of these items starts to bubble and fizz as I pour this acid over it. Now I'm going to move the camera just a little bit closer so you guys can have a better view of what's going on inside the cups. But definitely get yourselves all set up for step 2. So now that the camera is a little bit closer and you can see all of our materials a little bit better, I'm going to move on to step 2. So I'm going to pour this vinegar or this acid over each one of these items just enough to cover it. And I want you guys to move on to step 3. So make those observations, see which of these items starts to bubble or fizz when this vinegar hits it. If you see anything like that bubbling or fizzing, it's a pretty good sign that there's a base and even maybe calcium carbonate inside each of these items. So I'm going to move on to that dark colored rock here. Then that limestone sample. All right, perfect. So are you guys noticing any chemical reactions here? I definitely am, and I'm noticing most with this chalk sample over here. So you guys can actually see tons of little tiny bubbles rising to the surface off of that chalk. So that actually totally makes sense because chalk is made out of calcium carbonate shells. So there's these little tiny marine organisms that have these calcium carbonate shells that are in chalk. So to see those bubbles happen totally makes sense. Now the leaf and the rock here, you might notice nothing's really happening. And it's not like this experiment went wrong or anything, but that's probably just a good sign that these two items don't have calcium carbonate in them, or at least not a lot of it makes up the structure. Now finally, we have the limestone substrate here, and you'll notice that the vinegar solution here got all chalky, it looks like it's hard to see. There's actually a ton of bubbles coming off of that limestone piece. And it's eroding slightly as well. So we already know that calcium carbonate makes up limestone, but it's really cool to see these chemical reactions actually happen live time. So as you guys noticed, there's a lot that can happen when we mix even small amounts of acids with small amounts of bases. And while this was all for experimental purposes within my own backyard, what do you guys think would happen if we dumped vinegar all over coral reefs? They probably wouldn't like that too much, right? Well, unfortunately, something very similar is happening every single day, and it's all because of carbon dioxide emissions. As humans, we burn things like coal, oil, and gasoline, and that releases carbon dioxide into the atmosphere. That carbon dioxide is then absorbed by the oceans, which reduces the pH of the ocean and makes it a far more acidic environment for corals to live in. That's when you get reactions like this, with that limestone sample inside that vinegar, right? That acid and the base mixing. And that's exactly what we don't want to see on our oceans or in our coral reefs. Now, I know that all sounds bad, but I promise it's not all doom and gloom. There's a lot of things that you guys can do in your day-to-day lives to help corals. Now, by doing things like just biking instead of driving to school or work, or also just turning off electrical appliances when they're not in use, you can have a major impact on corals, and for the better as well. Just by reducing your CO2 emissions, you can actually help decelerate ocean acidification and help our coral reefs in the long term. Now that's it for our experiment today, guys, but if you want to explore more coral-themed activities and more coral-themed workshops, feel free to follow us on Facebook, Instagram, or go to our website at coralrestoration.org. Fellow interns, such as myself, are actually making similar experiments that you guys can check out and follow along at home. Now, if you want to learn more about how to protect coral reefs, also go to our nonprofit website as well. They'll give you tips and tricks on how you guys can help coral reefs every single day. Now, thanks again for joining me today, guys, and we look forward to conducting more experiments with you soon.